Okay, in this video, we're going to talk about how to draw the graph of a hyperbola. Okay, the first thing we're going to want to do is figure out what the center of this hyperbola is. Okay, so my center is going to have coordinates 3, -2. Make sure you pay attention that this is the x coordinate because it's with the x, and this one's the y because it's with the y, because we could also have them turned around, remember? Okay, so this would be 3, -2. Okay, so I'm going to go ahead and plot that point. So 1, 2, 3, -2, 1, 2. Okay, the next thing I'm interested in is what a is. Okay, so a squared is related to the length of the transverse axis. In this case, a squared is this 9. Okay, and we know that's how much we're going to move in the x direction because it's underneath the x. Okay, so that means that x is equal to 3. Okay, so I can come over from my center, and this tells me how to move in the x direction. The length of my transverse axis is 6, so I have to move 3 on each side of the center. So from my center, I'm going to 1, 2, 3, and that'll give me that dot there, and 3 this way, 1, 2, 3. Okay, now we're going to do the same thing to figure out how much we're going to move in the y direction. So what's b squared equal to? And that's 25. So that tells me that b is equal to 5. Okay, so the length of the conjugate axis is actually 10. Okay, but it's the 5 that I need because that tells me how much I'm going to move up and down. Okay, and again, that's in the y direction because the 25 was under the y. So from the center, I'm going to go 1, 2, 3, 4, 5 up, and 1, 2, 3, 4, 5 down. Okay. From here, I'm actually going to draw a rectangle. When we were doing ellipses, you could actually have drawn your ellipse, just connecting your points, making it somewhat elliptical. Okay, but now since I'm drawing a hyperbola, I'm actually going to I'm going to kind of make these dotted lines. I'm going to draw a box, or a rectangle, around these 4 dots, using those as on the sides of the rectangle. Okay, again, this is not part of the hyperbola, it just helps me draw it. Okay. And then, once I have that done, I'm going to make a line. I don't know if that actually got my line for me. Okay, that passes through the center and is the diagonals. Okay, and again, oops, I missed. Let me try that again. Let me undo what I just did. Okay, it's going to pass through the center here. This is actually the asymptotes for it. Okay, so again, I'm just using dotted lines to do that, and it's going through the center, and they should be straight lines. Okay. Okay, so and they're just the diagonals of the rectangle. I do this much better on paper. Okay, now you have to decide where the hyperbola is actually going to be. Okay, so you have a couple choices. It can go this direction where the purple dots end up being the vertices, or it can go this direction with the red dots. Okay, how you tell is you come over here and which variable is first. Okay, and you say, oh, the x is first, so that means the transverse axis is horizontal. So the red dots are my vertices. So when I draw this, remember, it's not going to cross these dotted lines I drew in. Okay, let me go back and get my regular pen here. It's not dotted. Okay. Okay, so I'm going to draw this just so it comes down like this, and they just go off and they get closer to that dotted line that we drew in here, and then the same thing here. Okay. Again, this is a horizontal one because the x comes first here in your equation. Okay. If you wanted, you could actually plot a couple more points, maybe find x-intercepts. We actually already have the y-intercept because it ended up being my vertex here. Okay, but if you want a little more exact graph, you could plot some points, right? Just think about what the domain is going to be. Your domain is, you have to put numbers in from -infinity to 0. You can't put anything in from 0 to 1, 2, 3, 4, 5, 6. Well, you can put 6 in, but anything between 0 and 6 you can't use because there's no graph there. Okay, so then you could put numbers in bigger than 6. So if you're going to try plotting points with it, you need to make sure you consider what your domain of it is. Okay, so in this case, my domain is from -infinity all the way to 0. Okay, and then it picks back up over here at 6, right? And the 6 is actually coming from because my one vertex is on the y-axis, and I went over 6, which is the length of my transverse axis. Okay, hopefully this helps. Okay, what if my equation would have looked this way with the y first and then the x? And you notice I didn't change any of the numbers up here. Your center is still 3, -2. Right? In this case, A is going to be 5, but that's still moving 5 in the y direction like I did up here, right? So this purple dot would still be there, that one would be there. Okay, your B would be 3, but you'd be moving 3 in the x direction. Remember, that's what I did with the red dots. Okay, I would draw this exact same box. I'd put the exact same dotted lines for my asymptotes in, but now where would the graph fall? Okay, so if you think about this, for this one here, circle it in purple, okay, it's actually going to be the graph that would come like this, okay? So the black graph would not be there. Oh, I missed big time. Okay, the black graph would not be there, and you'd have that graph right there, and I can actually erase my black graph. I remember where my eraser is, okay? And I would get rid of this piece of it, and now it's the purple graph. And you notice all I did was flip around. The y came first instead of the x, and that's the difference in my graph. Okay. So now when if you were going to plot extra points, you still have to worry about like what's your domain, right? Right, so can x be anything I want it to be now? And actually it can, if you notice. X can be anything I want it to be, but it's the range that gets restricted. So the range, you have no y values. Let me get my pointer. No y values in this part, right? So this is 3, 4, 5, 6. So from -7 up to 3 is not included in your range.